In this video, what we are going to see is the position of hydrogen in the periodic table. The explanation of position of hydrogen in the periodic table. Before that, let's see the position of hydrogen in the periodic table. Hydrogen is the simplest atom placed in the top of the periodic table along with the alkali groups, as the properties are similar to that. Now let's see what are the points which supports the position of hydrogen in the periodic table. Hydrogen has the electronic configuration of 1s1, which is resembles to that of the 1s1 general electronic configuration of the alkali metals, 1s block elements, alkali metals. Now we are going to see how it resembles. Hydrogen forms unipositive ion like that of alkali metals. For example, sodium, if it loses one electron, it forms Na plus ions. Similarly, the K plus and the cesium cation also formed if it loses one electron. Hydrogen also forms the cation unipositive ion like that of alkali metals. The resemblance in one property. And also the alkali metals forms halides. With the halogens it forms halides. Similarly, hydrogen also forms hydrogen halides, HCl, HF, HBr. Sodium forms alkali metal, sodium form. With the chlorine it forms sodium chloride. With the bromine it forms sodium bromide. With iodine it forms sodium iodide. And also with sodium alkali metal sodium, with the oxygen it forms sodium oxide, sodium peroxide and sodium sulfide. Similarly, hydrogen also forms hydrogen oxide, water peroxide, hydrogen peroxide and hydrogen sulfide. So similarly, the hydrogen resembles alkali metals in the formation of these compounds. And hydrogen, it also acts as a reducing agent like that of alkali metals. So these are all the properties hydrogen resembles in alkali metals. In the formation of unipositive ion, in the formation of halides, oxides, peroxides and sulfides, and the formation of oxides, the hydrogen resembles alkali metals. So on comparing the property of alkali metals with hydrogen, the ionization energy of hydrogen is more than that of alkali metals. The hydrogen possesses the high ionization energy of 1314 kilojoules per mole, but the alkali metals possess the low ionization energy of 377 to 520 kilojoules per mole. So ionization energy, what is ionization energy? The tendency, the energy needed for the removal of valence electron from the neutral gaseous metal atom. The ionization energy of hydrogen is very high than that of alkali metals. Then the property of forming halide ion. Halide ion, like that of halogens, hydrogen also form hydride ion. Halogens forming halide ion by the gain of one electron. Hydrogen also possesses the property, it accepts one electron and forming hydride ion. Halide ion, hydride ion. So by forming the hydride ion, the electronic configuration is similar to that of the noble gas helium. But in the attraction of electron to form the hydride ion, the electron affinity of the tendency to attract electron, the tendency, electron affinity of hydrogen is much less than that of halogen atom. That we can infer from this value. For example, hydrogen accepts electron and forming hydride ion. It is an endothermic reaction of the energy 36 kilocalories per mole. But in the case of halogen, it is an exothermic reaction. It accepts electron forming bromide ion. From this we can infer that the electron affinity of hydrogen is much less than that of halogen. So hydrogen resembles, in certain properties it resembles alkali metal, in certain properties it resembles halogen, but the common oxidation state is +1, thereby like that of alkali metals, it is the oxidation state of alkali metals are +1. So along with the alkali metals, in the top hydrogen is placed in the top of the periodic table. So the resemblance with the alkali metals, these are all the points, but how ionization energy differ from the alkali metals. In resemblance with the halogens and how it differ from the electron affinity and the final justification. So these are all the factors which accounts for the the portion of hydrogen in the periodic table. Subscribe for more videos. Thank you.